Hello and welcome everybody. My name is Moiz and I'm going to talk about predicting customer churn with machine learning. Alright, a little bit about myself. I'm a data scientist currently working in a fintech space in Toronto at the junction of finance, economics and machine learning. Me and my team are working on inventing some novel time series application to predict the recovery or I would say predict the economic recovery after COVID by certain industries. I'm a very active open source contributor, and in last 2 years I've been working to develop a library called PyCaret, which is an open source machine learning library in Python. I'm going to use that in my demonstration today. So what is PyCaret? It's an open source low code machine learning library, and it's an end-to-end model management tool in Python. It's commonly used for prototyping and deployment of end-to-end machine learning pipeline. It's a very user-friendly tool targeted for business audience and perhaps people with not so heavy computer science background. Some statistics. We have released our first public version in April of 2020, and we have 500,000 plus downloads so far. We have more than 3,000 git stars, 1,700 plus commits in last 1 year, and the number that I'm most proud of is 46 contributors from community who are actively working to build PyCaret. Alright, so what is customer churn? Customer churn, think it as a percentage of customers that you will lose to your competitors, or they would go out of business or whatever, right? So if you had 1,000 customers at the start of the period and at the end of the period you have 950 customers, so you have a churn of 5%, 50 divided by 1,000. How is customer churn is predicted using machine learning, or what's the application here, right? So what you see is a very visual way to understand what's going on here. So as a company, you would have your customer history database where you would have your customer dimensions, the location, the business unit, pricing plan, etc. Using that, you would train a machine learning model, which is this blue box in center, and every month you are going to take your existing customer base and pass it to this machine learning model. And what it would do is it would separate out the happy customers, which are less likely to churn, versus customers that are at the highest risk of churning. And what you want to do is, once you predict those customers, so imagine at every month end you would be creating a feature or data set that you would pass to machine learning model. It would tell you that who are your highest risky customers with respect to churn. And then you would transfer that list to customer retention department to do some kind of intervention to stop the churn, right? So that's the business value of project. Something to be careful about in machine learning or churn related projects is you have two things. You have event and you have performance window. Event is basically the time period using which you are training your model. So because when you're predicting churn, you want to take care of that time lag, right? Because you at least have to predict 1 month in advance, 2 or 3 or 4 months in advance, depending on business use case. But the point here is you have to predict it in advance. So there has to be a lagging time period, right? Because you want to predict in advance so that company or customer retention team has time to intervene and stop the churn, right? That's the whole idea. And the last date of your event period is your cutoff date. So if today is 31st May and you want to predict whether the customer or your existing customer list who is at the risk of churning by end of June, then your performance window is June, right? If you're only talking about 1 month lag. So this is something you have to be take care of. Otherwise, it's very easy to kind of pass the leakage in the machine learning model, so that you would think that it's a good model, but when it would start performing on real life data, unseen data, it wouldn't be as good as you would have perceived. Alright, this is a high level workflow that we are going to follow today. We will use it, but it's a very generic life cycle. Can be applied to any supervised machine learning problem. Any problem starts with business problem, the first box on the left hand side. Then you have data sourcing and ETL, where you collect the data. Then you do exploratory data analysis. You examine your data. You draw hypothesis from your data by visually looking at it. Then you have data preparation for machine learning, which involves a couple of steps, 20, 25, 30 steps. And then you have model training and selection, where you actually take the pre-trained algorithms and fit them on data, multiple of them, and then you tune their parameters, and you do a bunch of things basically to come up with one final algorithm that's doing the best. And then you deploy that model. PyCaret fits in here in these two right boxes. So using PyCaret, you can do this iteration very quickly. All right. Okay, so here's the data set I'm using for this demo today. It's a telecom customer churn data set from Kaggle. The link is down here in presentation. Basically each row is a customer, and you can see various attributes of customer, and the last column here represents whether that customer has left next month or next month or whatever. I don't know the time period here, but it basically says yes or no, right? The next phase is exploratory data analysis, and as you can guess, with any churn related problem, the most important thing here is your contract, right? Are you a month-to-month customer? Are you locked in for a year or 2 years? So what you see here on the screen is basically three facets. The first graph on the left hand side is month-to-month, then 1 year, then 2 year. On your x-axis you have customer tenure, how long have been the customer with the company in number of months. Your y-axis is total charges, that's your total bill per month. And the red and blue dots are basically represented by churn or no, right? So yes or no. Red color or orange color is yes. And you can see in a month-to-month contract, the most of the churn is here in the first graph, right? Kind of makes sense because if your customer has like 1 year lock-in contract, you would have less churn there. All right. To prepare the data in PyCaret, you basically import the module. So this is the code you would write in Jupyter Notebook or any of your IDE or whatever you are using for Python. You would import the classification module, pass the data. This is the data frame called data. Pass the target column. Churn is the name of the target column. And then I'm ignoring customer ID features because I don't want to train models on customer ID. It's a unique identifier, right? And you can see we had 7,000 data points. It was divided into two sets, train and test, 5,000 and 2,000, right? This is how you actually evaluate the performance of your machine learning models. The first thing you do after setup, your data is actually ready for training. So you basically pass this command from PyCaret, compare models, and it would train a bunch of models using cross-validation. Cross-validation is a way how you evaluate your models, and it would give you this list out here. So the way you would read this table is each row is an algorithm here, and each column is a metric here. And you can see AUC is one of the metric for measuring the model performance. And you can see gradient boosting classifier is the best model in terms of AUC, right? Look at how easy, just one word here, just one line of code, and there you go, you have your best model. If you want, you can analyze the performance of models. So with just one line of code, you can see the feature importance. Tenure is the most important feature for algorithm to predict the churn. Contract month to month. Online security no. Blah blah blah. Right. This is AUC plot. This is the number we were seeing on the other table, 85. Confusion matrix. This shows you this. So basically, four quadrants. The one here bottom right is true positive, on the top here is true negative, this is 138 is false positive, and this is false negative. And if you attach dollar to this by just making some business assumptions, so I'm assuming that every time you would predict you would have a true positive, you would be able to intervene and stop that churn, right? So 309 is your true positive, and every time you do that, you extend the customer lifetime value by $5,000. So you multiply by 5,000 by 309, you get 1.5 million. And the way you would intervene, you would offer some kind of refund some kind of voucher, gift voucher, or something like that. I assumed worth $1,000. So you'd pay 138 plus 309, 447 customers. You'd pay $1,000, and you net this number. So the business value of this model over 2,000 customers, if you sum up all these, you would get 2,000 approximately, is $1.1 million roughly. And these are business assumptions, right? But the problem here is, if you've seen, like, I've optimized a generic machine learning metric, right, AUC. Now, after the fact, I calculated the dollar amount, but I actually didn't feed it that intelligence to the model. What you can do in PyCaret is actually write this 2 lines of code and pass that intelligence through add metric function. And now if you notice, it's the same table except that we have a new column here, profit. And if you notice, this is now our best model based on profit, which is naive Bayes. And our best model based on AUC, which is gradient boosting classifier, is now number 5th, right? So now I'm making a right decision in terms of choosing a model that matters most to the business, right? This is the new confusion matrix. Obviously, when you sum this, the numbers are still 2,000, but the proportion between true positive, false positive, and false negative has changed. So this was before 1.1 million, and this is after. So using naive Bayes, we are now making 1.5 million, approximately 1.45 million over 2,000 customers. All right. That brings me to the end of my talk today. I'll be happy to take any questions.